So it's a review for the big test. This is the harder probability test. It's called probability B. When I said there were 3 shots at the end of the game, that meant that there was a 3 there. Only reason I'm not yelling at you for talking is I know you're talking about this problem, but if you can tone it down a little bit, that would be great. I said you were going to make exactly 2 of those 3 shots. Here's the making kind. I would even label it with make. You don't have to, but it helps you to understand the question. If you make, and then I want it to make 2, then I'd have a 2 here. And then this would be miss, and these all just follow logically from the others. And this must be 0.25. And then if you make 2 of them, you must miss 1 of them. And that is something you could do on a calculator. Ike, exactly what did you get?
0.422.
422. I know you're right. Raise your hand if you are agreeing with him. You were right. Yay. Okay, good. That's one kind of question. Now, how could it have been made significantly harder by just adding 2 words to it? I'm going to review the question, and you try to figure out where you'd have added the 2 words. What is the probability that you make 2 out of the 3 shots? What little 2 words could you add to that to make it way harder? Yes?
At least.
At least 2 out of the 3 shots. Do you get then? You would have had to figure out the probability of making 3 out of 3 also. And then you'd add them together. All right. Another variation on this goes like this. And I'd like you to set this one up. What's the probability that you make at least 1? Now, if you're going to make it really complicated, you're going to write 3 formulas out right now. But if you know the smart way, think about it. What's the probability you're going to make at least 1 shot? At least 1. Wouldn't you have to do 1 and 2 and 3? There's another way that's smarter. You could figure out the probability of making no shots and having 3 misses, and then take 1 minus that. Raise your hand if you understood what I was talking about. Okay, good. Now let's move on to the second type of process. That was expected value. I taught you that ahead of time. Then you had a video where Mrs. Wiedela explained it, and the sub said it was a pretty good explanation. And so now you got a third chance to talk about expected value. Imagine I give you 4 envelopes to pick from. They're all black envelopes, so you can't see inside them, and you can't, influence your probability. So you're truly randomly going to get either nothing, $10, or I'm going to add a little twist. There's 2 of them that have $5. Now, would you pay $1 to play this game? Yeah, that'd be a great deal. You'd only lose 1 time, and 3 out of 4 times you'd win. In fact, you'd win a lot. All right. So if I said there was a charge of $2, I think you'd realize it's still a pretty good deal. But please figure out your expected value if it costs $2. Now, by the way, I think you should just factor that in at the very end. I would do everything the same as normal, and then just do something at the very end of the problem that factors in that it costs $2 to play. Now, this always involves probability, of course, because it's in the test called probability. And I said the shortcut would be to remember it was P times A. See if you got this. All right, if you were setting it up right, then you probably would get to this pretty quickly. P times A is probability of, well, it's 1 in 4 chance times the amount you get is 0, but that's going to just equal 0. This one, probability is 1 in 4 chance times the amount you get if you hit that is 10. And then 1/4 of 10 is $2.50. 1/4 times 5. Now, some people confuse themselves by going, but isn't there a 2 in 4 chance that you're going to get $5? There is. But you can't say there's a 2 in 4 chance and a 2 in 4 chance and then do it twice. You could say that there's a 1 in 4 chance of getting this envelope plus a 1 in 4 chance of getting that envelope. Or you could put them together and just do it once and say there's a 2 in 4 chance of getting 5. All right. This would be 1.25, and this would be 1.25. And then last hour, I was like, it was driving me a little crazy because nobody was saying the answer was 5. But the answer wasn't 5. It's kind of 5. These do add up to 5, but why is it not 5? Yeah, your expected value is not $5 because you have to pay 2 to play. Who had 3? Raise your hand if you had 3. Okay, good. See, this would add up to $5, but you can't say you're going to win $5 every time because you're paying 2. I would subtract that out at the end, and then your EV would be 3. Now, one more thing. Pay attention here. Let's say that this is at a charity fundraiser. Is it going to raise a lot of money for charity? No, because the people who play the game are going to win $3 every time, on average. So that's a bad deal for the charity. What should they have priced it at? $5? If they charged $5, do you get the expected value would be 0? Well, then isn't that a good game to raise money for charity? Yeah. You're not going to make anything, but neither is the charity. See what I mean? So the fair price is $5, but you don't want it to be fair if you want it to be a fundraiser. If you want to earn some money for the people who are putting on the game, they probably charge you $6 or $7. If they charge too much, nobody would want to play. Charge $10 to play this game, and maybe you get your money back. Yeah, that'd be a sucky game. So they usually set it at just enough so that it's in their favor, but so it'd probably be $6 to play. And then people are like, well, I'm only losing $1, and I'm hoping I'm going to hit that one. And $6 to play is actually going to lose you money over time. Because if I subtract 6 on average, you're going to lose $1. Negative $1 expected value. All right, let's move on to the third, and I think probably hardest kind, and that has to do with CC over C. Everybody start with just writing that. I'm promising, though, that the first question is not going to be a CC over C, but it's in this category. All right. So, just scanning throughout the room, I'm going to say that there are 3 people that I would have identified in here as blonde. And then I'm going to say that I'd say there's 12 people I would have said have black hair. And there's about 15 of you that have what I would say isn't blonde or black. Something else. Could be red. Could be some shade of blonde, but not quite blonde enough. I call it blonde. I mean, it's really hard, especially with blonde, to judge whether a person is really blonde or if they're got just light brown hair or whatever. Okay, so here's our numbers. My question for you, I promise it's not a CC over C, is how many different ways could I choose 3 kids, the end? Sometimes the simplest questions can be hard to like figure out, what do you mean? Would you please write down what you think you should do? You don't even have to type it in. I just want you to tell me, what should you do? Well, if you've added them up by now, you know that there is 30 kids. 30C3. Don't overthink it. I just said choose 3 kids. That's it. Did I say that the order mattered at all? No. If I had said the order mattered, then you'd change it to a what? P. The order patters on the P's, okay? This one, the order doesn't matter, so it's just 30C3. All right, now, a medium question. If I had chosen 5 people, how many different ways could I get 4 people with black hair, 5 chosen, 4 with black hair, and 1 with blonde? If there's 5 kids that were picked, how many different ways could you get 4 people with black hair and 1 with blonde hair? Come on, John. Blank on the village deck. Try that problem. I'm not wasting your time. Every single one of these things is represented on your test. Or something like it. Kenneth, did you realize it was a C question? Yeah. Now, some people will include a third C, but you don't have to. Show me how you could do it with 2 C's. Kenneth, you got this? Yeah. All right, I'm going to give you a hint. 4 black. Let's do black here. Starting with 12 black-haired people in the room, then what? Yep. Take it over from there. Nope, wait, a different kid. I'm going to call on somebody else. Durant.
Then for the other C, we would put 3 in front, and then a 1.
You got it. That's it. And I know you all know how to type those into your calculator, so that's it. Now, if some of you are like, well, what about the other kids? Well, there's 15 of them, and we're going to choose 0. And if you want to include that, I wouldn't say it was wrong, but you don't have to, because what's that going to equal? It just comes out to 1. If you're going to choose 0 of something, there's only one way to do that. Okay. All right. Now, not the hardest question yet, but medium hard. What's the probability, if you choose these 5 people, that you're going to get 4 black and 1 blonde? That changes the question because it's probability now. What's the probability, if you choose 5 people, that you're going to get 4 with black hair and 1 with blonde hair? And I know it seems like it's the same question, but it's not. Did you know that that meant we have to make it a CC over C? And now, pay attention to this. This is important. It's a really common mistake to say 15, choose 5 down here. Because 12 and 3 add up to 15. Now, that is true. 12 and 3 do add up to 15, but that should not be a 15 down there. Jaden, what do you think it should be down there? This is about the totals. They go on the bottom. It's definitely not 15. I'm going to give you this hint. It is 30. Who had 30? Raise your hand if you had 30. Okay, good. Now, you might be disturbed by the fact that these don't add up to 30. What the heck? If you include that third C and say that there were 15 others and we choose 0 of them, then it'll add up to 30. But I won't change the answer, weirdly. All right, and now the hardest one. I know some of you have gotten to the point in the class where you're kind of drifting. Snap out of it. This is the hardest problem I've given you so far. Okay, you ready? We're choosing 7 lucky people. What's the probability that 4 have black hair? As soon as I say the probability, I think I've got you trained in well enough. You know there's a C on the bottom, right? I actually think it's easiest to start with the bottom and go, well, how many people was I picking from? Oh yeah, there was 30 people. And how many people was I picking? I was picking 7. And then you do the more detailed thing on the top. And it feels like it should be CCC, but that would mess you up. Because as soon as you got done with the black-haired people, which would be 12, and I'm choosing out 4, you'd be really struggling with the other 2 C's. Caleb, how do I do it instead?
Just group the other blonde people together so that there's a group of 18 and there's 3 kids in that group.
So there's how many total in that group? 18. Choosing how many? There you go. Raise your hand if you set that one up right. Cool, that was one of the hardest questions. Now, I'm gonna add this other question in because I'm not gonna tell you how to do it. And I think a lot of you are gonna struggle, so therefore you'll see it's hard. Okay, question, anybody have a clarifying question on this one? I thought I saw a hand. Okay, then, here's the last one, and again, I'm not gonna give you the hint on like how to set it up. So, let's see if you get this. If I pick a number that's in the 700s, okay, like 753, okay? And it's a 3-digit number, my question is actually, I pick a 3-digit number and what's the probability it will be in the 700s? Now there's a lot of different ways you could do this one. And I'm going to give you a different version of it before I even show you how to do it. This version of it is how many ways can you make a 5-digit number? I'm changing their question. This is a different question. I'm making 2 separate questions, okay? The black written question is different. How many different ways can you make a 5-digit number that is at least 60,000? How many ways can you make a 5-digit number that's at least 60,000? All right, so did you notice that the first time we did problems, I gave you the, like, here's how we're gonna do this. And then I gave you the problem, and that makes it so much easier if I tell you. Like, one set of problems was about doing CC over C, and you knew we were gonna do it that way. Another one I said we're gonna do the binomial, so it's got the C in front and two parentheses. Once you know the right system, these aren't that hard. Here's how I would do these. I would do these with blanks. If it's a 3-digit number, both of these problems, no wait, the first problem was in 3 digits, the second one was at 5 digits. Then when you do it with blanks, you should use how many choices you have. If this number was going to be in the 700s, how many choices do I have for this digit right here? Could it be a 7? Do I have 7 choices? How many choices do I have? Just one. I only have one choice for that. Because 8 is not in the 700s. I mean, if I had said at least 700, then you could have 7 or 8 or 9. But I said 700s. All right? There's only one choice of that first digit. How many choices are there for this digit and this digit? Couldn't it be like 706 or 723? And it doesn't really matter what these last two numbers are. So then there's 10 choices for this and 10 choices for that. I know it doesn't feel like there's 10 choices, but when you include 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10 choices. Now, why can't this possibly be the right answer? Because it's a probability, and so far we've got this really huge number. So what do you have to divide by?
10 times 10 times 10.
Yes, this is all the possibles. It could have started with anything. Now, I know some of you are going to argue, well, I did it a different way and got a different answer. Well, that's fine. If you, or wait a minute, not if you get a different answer. If you get the same answer, that's fine. You can do it this other way. So there's 100 out of 1,000. Do. 1 in 10 chance. Now, I could have done it a different way. Totally could have thought, well, it's either going to be in the zeros, as in it would start with 0, or it could be in the 100s, or the 200s, or the 300s, or the 400s, or the 5, 6, 700s, 8, 9, or, yeah, start with the 900s. So there's 10 things it could have started with, and there was only a 1 in 10 chance it would start with a 7. I would have bought that and said 1 in 10 was also okay. But 1 in 10 is the answer. Yes?
Wouldn't it not be 1,000 though, because you can't have the numbers that start with 99 or 1,000 because those are 3 digits? Because you said only 3-digit numbers.
Yeah, I get what you're saying, but it would have, if we had this question, it would have to say that starting with a 0 is a legitimate number. Like, I'll give you an example. You've got like a combination lock, and you can start a combination with a 0. And it's still a 3-digit number. 030 is a 3-digit number, even though that's really 30. Do you get what I'm saying? So I hear you. I get you got an exception there, and it should clarify in the question that numbers can start with a 0. Okay. All right. So on to this one. Now that I told you to do blanks and how many choices you have, try this one. If you didn't do it that way before, try it that way now. How many different ways can you make a 5-digit number that is at least 60,000? So ask yourself, how many choices do I have for this? Does it have to start with a 6? No. Can it start with a 6? Yes. So it's going to be a 6, 7, 8, or 9. Who had 4 there? Raise your hand if you had that. Awesome. Then these, I know you get in the pattern sometimes on these problems that it's going to be like 4 times 3 times 2 times 1. Nope. You got to ask yourself, what choices do I have for this digit of the number? Couldn't it be anything? And how many choices are there? 10, and 10, and 10, and 10. So if I actually wanted the answer, it's a 4 with 1, 2, 3, 4 zeros. There's 40,000 different ways you can make a number that's at least 60,000. All right, one last twist on this question. What if you can only use the digits 4, 5, and 6? Now that totally changes your answer. I'd still use blanks. If you can only use the digits 4, 5, and 6, how many different ways can you make a 5-digit number less than, no, at least 60,000? So remember, it's how many choices. So Ike, how many choices do I have for this spot right here? Nope, because if I start with a 5, it won't be at least 60. There you go. 1. How many choices for this spot?
3.
And the rest of them are all 3s. Who had 81 for your answer? Nice. If you didn't know what 3 times 3 times 3 times 3 was, it's 81.